Hello guys, thanks for joining. In this video, we'll talk about dynamic programming and how we can use dynamic programming to solve LeetCode problems. And these are a very important concept because most of the tech companies, in fact, they usually ask one or two dynamic programming problem in the interview. So yeah, let's get started. So even before starting dynamic programming, we need to know what is recursion because this is a very important concept when you are trying to solve coding problem using dynamic programming. So recursion is a special type of function which calls itself inside the function. So the example would be something like a Fibonacci series, right? So in Fibonacci series, you have some numbers like 0, start with 1, 1. And for the next number, you basically sum up the previous two numbers and you get the next number. So if you add up 1 plus 1, it becomes 2, right? And then if you add 2 plus 1, so it will become actually 3. So basically for each of the numbers, you add up these two numbers, you get the next number. Same as like here and also here, right? And if you want to get the next number, it will be 3 plus 2. So you add those two things, it will be 5. So this is the Fibonacci number series, and it goes like this way. So if you want to write a function to calculate this Fibonacci series, obviously you can take a look at it. The first number, call it with this 0, the return should be 0, right? If you call it with 1, you should return 1. If you call it 2, it should return 1, right? So the first three numbers starting with 0, 1, and 1, right? So let's change this color. So this is your first number, this is your second number, and this is your third number. For each of the next number, what you basically want to do, you basically want to, for f of n, you just multiply the previous two number. So if you can write a function in your preferred language like Java, Python, or C++, whatever you want to do, for each of the function, what it basically is doing, it's trying to calculate the previous two number and then sum those two numbers up, right? So what happens then? So you can see a picture here with a recursion tree where we want to calculate from the top-down approach, from the top to bottom. And our function is Fibonacci of n is equal to Fibonacci of n minus 1 plus n minus 2. So for example, if you have to calculate f5, the Fibonacci number of 5, you need two values like f4 and f3. And for f3, you need actually f2 and f1. And if you go to the left branch, you will see actually for f4, you need f3 and f2. And I color-coded these two nodes like f3. So you see actually these two f3, you have same color. Same as like f2, I put it as a green color. So when you are calling this recursive function, this guy with fn minus 1 and fn minus 2, you basically need for even for f5, right? When you are calculating f5, you need actually f3, which you already calculated might be if you already calculate f4, right? So because f4 needs f3 as well, right? So if you write a recursive function, which you'll call recursively from the top-down approach, the main problem is that you are calculating these f3, f2 multiple times, right? So that's where this recursion might be a little bit tricky because you are not very smart about your space uses or actually the calculation uses. So let's talk about how it can be solved using dynamic programming. So if you go to the dynamic programming, so it's similar to recursion, but there are two key concept in dynamic programming. So it needs to have some sort of optimal substructure. That means you would be able to write this function using some sort of like recursive functions, right? So if you, for dynamic programming, if you can't write something like this, fn minus 1 plus fn minus 2, or any of the recurrence relation, this is called a recurrence relation. If you can't write using recurrence relation, then the dynamic programming would not be useful. So when you're trying to solve a dynamic problem, just think about, is there any optimal substructure where you can write down a recursive function, right? And second thing, actually, is there any value you are calculating over and over again? For example, when we are calculating fn, we need fn minus 2, right? And when you are calculating fn minus 1, you again need fn minus 2. So you see, actually, these two values are same, right? So is there any overlapping subproblems, right? So if you go back to the previous screen, you will see when you are calculating F5, you need F4 and F3. And for F3, you need F2 and F1. So you need F3 to calculate both F4 and F5, right? So somehow if someone tells you what is F3 is, then you don't need to calculate twice, right? In this picture, even for F2, right? If you already know what is F2, you don't need to calculate twice for F2. Just to reiterate, the dynamic programming needs actually at least two properties. One is actually optimal substructure, so that you can write a recursive function to calculate some value. And second thing, is there any overlapping subproblems? That means whatever you calculated before, can you use it for the next time? There are two ways to write dynamic programming or solving dynamic programming problems. One is top-down approach, another one is bottom-up. From the top down, you start basically from n and then goes to the base case 0, right? So from n, you want to calculate n minus 1, and then n minus 2, and n minus 3, finally go to 0, right? For the bottom-up approach, you basically start with the 0 and then calculate 1, 2, 3, and go to the n, right? So there's some advantage and disadvantage for both the approach. And for the top-down approach, it's really easy to write down the recursive function, right? Because what you do, actually, you want to calculate fn only if not computed before. And you want to store it in the cache on dictionary, right? So if you go to the previous picture, you see actually for F5, you need two things, right? So F4 and F3. So basically what you do, you calculate F3, and as soon as you calculate F3, you store it somewhere in a cache or dictionary or hash map, right? And when you're calculating F4, you need F3 again. What you do, actually, you don't calculate F3 anymore because you already calculated. So you use that F3, right? So that's how this top-down approach works. What about the bottom-up? For the bottom-up approach, since you are starting with 0, you basically use the previously computed results to calculate the new value, right? So you go from 0 to 1 to 3, right? And since we are talking about LeetCode problems, most of the problem you will be able to use it using bottom-up approach, and it's pretty easy if you can write down somehow, know the base case, and also come up with the recurrence relations. So same problem for the Fibonacci series, but for this tree, we are basically starting from bottom up, right? So you are starting from these downside. So you basically calculate F1, F2, and F3 in this way, right? So at first you write this recurrence relation. This is your recurrence relation. You start with F0, and you know actually F0 is 0 here. And for F1 is also 1. And then F2 is also 1. And basically what you want to do, if you already have these three values, or basically if you have only two values, F0 equals 0 and F1 is 1, you can compute from 3 to n using this recurrence relation, because F3 would be nothing but you just add these two things up, F2 plus F1, which is 1 plus 1 becomes 2. So these will becomes 2, right? These whole things will become 2. These things will become, you already calculate F3. So F3 is 2, and you just add 1. So then you get the next value. Same as you go to F5, right? So when you are calculating dynamic programming bottom up, you basically start from the 0th state and just go up from there, right? And now, what are the LeetCode dynamic programming problems? So I would suggest start from the easy problems, right? So at first, just try to write down this LeetCode 509, right, with the Fibonacci number, right? And the similar problem is like climbing stairs. This is 70. And then try Pascal triangles, right? Try to solve first a few easy problems, at least I would say 5 to 6 problems, which are LeetCode easy, right? Then go to the medium one so that actually you can gradually learn the tricks first, and then you can think about how you can approach those problems, right? So even for this first problem, right, 509 Fibonacci, you can, if you want to write it in Python, the code would be something like this, right? So you are calling a Fibonacci function. If your n is less than 3, you basically return 0 if n equals 0, or otherwise you will just return 1, right? So if I go back, so you see for 0 is 0 and 1 and 2 is both are 1, right? So if it is less than 3, you basically return 0 for n equals 0 or else 1. Otherwise, you are storing in a table like a list or array. So basically for dynamic programming, it's convention just use DP as a short form of dynamic table, right? So what you do actually as a DP list, you just put all of them with 0, n plus 1. And now you define these two values, right? So DP1 and DP2 both are 1, right? Then from n to starting from 3, you want to n plus 1, you want to calculate all the values. So basically you have dpn minus 1 and dpn minus 2, and sum these two things up and put it to dpi, right? So this for loop will run actually for from 3 to n. And finally, your dp has all the results. So basically you just want to return all the results, right? So for this algorithm, it's you are running order of n, right? So because you have a for loop, so basically you're running order n. And for space, you basically need same as like order n, because your list size is also n, right? You can do something better, right? So because if for dpn, you don't need whole values here, because you need only previous two values. So what you can do actually, you can just change it, this DPI to A, this one to B, and this one to C, right? And you just keep updating the values. So basically you can do it in constant space, but using DPI will give you some sort of idea how to use this format in other dynamic programming problems too. Yep, so that's how you can solve all these dynamic programming problems. If you want to get more update about how to solve LeetCode problems, you can take a look at the YouTube playlist, and you'll be able to see the next problem Fibonacci series, how I solve it using Python, and maybe in the next one. I'll see you in the next video. Thanks for watching.